Well, hello. Let's go over the Chapter 4 test. So the first question dealt with simplifying some monomials, and there were four of them that were presented. So let's look at one way that you might think about these. In the very first problem, I do have a case where I have a certain power. I have b to the third power, so there are three factors of b there. But that expression is being raised to the fourth power as well. So I know when I do this, I have not just three factors of b, but I have four groups of those, right? So I've got BBB, 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 BBB. This is literally b to the 12th power. So the first part of that I'll write as b to the 12th. And then beyond that, you can see I've got two factors of b and 1, 2, 3, 4 factors of b. So this is times b to the 6th power. So there's just a point where we need to start internalizing this and thinking about, what does an exponent tell us, and how many factors of, in this case, b do I have? Together, because I have 12 factors of b multiplied by 6 more factors of b, there are a total of 18 factors of b. So the answer for A is b to the 18th power. There are 18 factors of b. Let's look at part B. One of the things I see in B is that there's a common factor here, right? And I can write this out. I've got 16 is 8 times 2, and in my denominator I've got an 8. So there is a giant 1 in the form of 8 over 8. The rest of the problem, then I've got x to the third power, and then down below I have x to the negative third. One of the things that I see often, and it's a little alarming, so this idea that what we're looking at here is a giant 1. We're not. X to the third over x to the negative third is not the same thing as x to the third over x to the third. This is different. If they were both x to the positive third, that would be a 1, and my answer would be 2. However, they're not. So one way to process this negative exponent is to say, look, I'm going to look at this negative exponent. I'm going to multiply it by x to the positive 3 in the denominator. And to keep this equal to 1, I'll put an x to the positive 3 in the numerator. The reason why I selected that specifically is when I look at these two things together equal x to the 0 power, and anything to the 0 power equals 1. So because I had the 8 over 8 form of 1, and now this is equal to 1, the only thing left in this denominator is 1. And in my numerator, I have a factor of 2. Right? And then I have 3 factors of x times 3 more factors of x. So that's x to the 6th power. So this is the answer to part B. Good way to take care of a negative exponent is to neutralize it with a positive exponent of the same form. Let's look at part C. In C, that's a D. In C, okay, so I've got another negative exponent here. Another opportunity to practice that. In C, you can see that there's this 5 halves times 8, right? You can see across here, it's just something times something. The commutative property of multiplication and the associative property of multiplication will let me do these things in any order I choose because it's just all multiplication. If I take 5 halves and I multiply it by 8, I get 40 halves, which is 20. Or I can take 8 divided by 2 is 4. 4 times 5 is 20. But in any rate, those things that I've highlighted are equal to 20. Across the numerator, I have 5 factors of a, right? There's 2 factors here and 1, 2, 3 factors of a there. So I have a to the 5th power. And I have b to the 4th power also. And then in that denominator, there is an a to the negative 2nd power. When I look at that a to the negative 2nd, right, I'm going to use the same technique. I'm going to neutralize that by multiplying both the numerator and denominator by a to the 2nd. This is the reason why I'm selecting this, is I know that this will make a 1. It will make the value 1 with the a to the negative 2nd. And the reason why I have to put it in the numerator is because in order for this expression to be equivalent to it, the result I get, I can only multiply by 1. So in taking this monomial, multiplying it by the number 1, I'm not changing its value, I'm just changing its format. Across the top now I have 7 factors of a. So my final answer would be that this is 20 times a to the 7th power, And I do have b to the fourth power. And again, this denominator is 1 because a to the negative second times a to the second equals 1. So this is what I would record for my answer. 28 b to the 7th times a to the, no, I'm sorry, 28 to the 7th times b to the 4th. And finally, part C is an expression that has just all numbers. What's nice about this is I think our calculators will evaluate this quite nicely. So you get kind of the opportunity to check if what you think you get is the right thing. But it also gives you a chance to practice and make sure you're understanding some things. So when I look at this in the numerator, I have 2 raised to the negative first power times 2 to the second power. Well, when I use one of my laws of exponents, that just becomes 2 to the first power. So that numerator is just 2 to the first, or 2. And in my denominator, I have 2 to the negative second power. So I can take that 2 to the negative second power, right, and I can deal with it the same way I've dealt with it twice here. I can multiply by 2 to the positive second power. Again, that will neutralize this negative exponent and make this 2 to the 0, which will equal 1. And in order to keep this value the same, I multiply the numerator also by 2 to the first. So the big thinking that's going on here is that this equals the number 1. So I'm multiplying by 1. So I'm not changing its value. I'm just changing how it looks. And then if I go ahead and finish this off, my numerator has 3 factors of 2, right? 2, 2, 2. 2 to the third. My denominator has just the number 1, and 2 times 2 times 2 is 8. So this is 2 to the third, or the number 8. And again, if we want to check this with our calculators, we can. In this case, I don't have one readily available, so let's move on. So that's the end of question 1.